There's a lot to like about the energy transition. We have the technology. We just need to deploy. But the battery industry is one of the more problematic ones. Most of the battery cells made in the world today come from China. And I have nothing against China. China is an amazing country. But there is potential for conflict between the U.S. and China when it comes to many things, including Taiwan, which itself produces 70% of the integrated circuits in the world. So we need to make batteries here at home. And my guest today, American Battery Factory, has a wonderful story to tell. They have their roots in Utah. They're now establishing themselves in Tucson with a gigafactory and global headquarters. And they are lining up the lithium supply chain. They are lining up the labor force, and workforce development is a front and center for them. They're using some very unique construction methodology, which you'll have to listen to the interview to hear Paul Charles discuss. And it's a true blue American company. So this is a real treat to bring you American Battery Factory. It's heady days in the clean energy transition, but we need a lot more batteries. I'm Tim Montague. Welcome to the Clean Power Hour. Check out all of our content at cleanpowerhour.com. Please give us a rating and a review on Apple and Spotify so that others can find this content. Today on the Clean Power Hour, American Battery Factory. My guest is Paul Charles, the CEO. Welcome to the show.
Thank you very much. I'm looking forward to having an active, interesting conversation here.
I love the name, and I know that's partly because of the name of the town where you were founded, but, we do need more batteries made in America. And, of course, the IRA, the Inflation Reduction Act, is breathing new wind into American manufacturing here in the winter of 2022. And there's I think over a dozen battery factories now slated to come to the U.S., and you have some recent news as well about a factory you're building. But give us a little background on yourself, Paul, and how you got involved with ABF.
Great. I certainly appreciate the opportunity today here. For the last 30 years, I've been commercializing technologies on a global basis here, some of which I've developed myself, and others been fortunate enough to be with very smart scientists and inventors and companies with that. But there's been a constant thread of energy focus throughout this. Early in my career, I started a company based out of Switzerland as well as out of the U.S., Silicon Valley, and in Scottsdale, in which we made accessories, peripherals for many of the laptop manufacturers on a global basis. Everything from battery chargers to auto adapters to docking technologies on that. And it was really an incredible experience, to say the least. Started off in my son's bedroom, and from there grew that over 11 years and had an exit with that. And then from there just did some interesting projects as well, too. On the power side, ended up going into Mexico and having opportunities to work with Pemex and CFE, the state-owned enterprises, on that. And then after that, had an opportunity to move from Scottsdale, Arizona up here to Utah and help put together a stealth nanotechnology entity in which we figured out how to take greenhouse gases and convert those into selectable nanocarbon, specifically carbon nanotubes, along with carbon black, and the only byproduct being distilled water. After doing that for quite a few years and being able to get the pilot stage with that, then exited from that and was introduced to a company here in Utah called Lion Energy. And Lion is really an interesting company. They're one of the fastest growing companies here in Utah, and they've spent about a decade providing product into the marketplace. When I say product, their focus is energy storage products. They design and test everything here in Utah. However, like the rest of the industry, they manufacture in China because China has the infrastructure. They have the understanding of how to build these things in volume. They realized a few years ago that it was kind of important to start to onshore. This is pre-pandemic, by the way, but they were missing one important thing, and that thing was a battery cell. And I was introduced to them, and they told me what their vision was, and I thought this is really great. This is something we absolutely need to do. But the challenge for them is to be able to have a U.S. manufacturing source for cells which were made specifically to last a long time with a safe chemistry and some other attributes with that. And so after understanding that, I went away and did some due diligence and came back and actually put together a proposal for them. And that was really the genesis of American Battery Factory. And so there's a few things that I want to make sure it's rather clear on that is American Battery Factory is a separate entity from Lion Energy. And our goal and focus is really to enable energy independence in America, but also to enable that around the world. Lion Energy has signed the first offtake agreement with American Battery Factory for 18 gigawatts over a 5-year time frame. And it's really been wonderful because it's not often you have a customer that is literally incubating the source of a key component in their product that they're taking into the marketplace. So we've had full access to a couple hundred employees, heavy on the engineering side of that, and it's really been a wonderful experience with that.
Yeah, I'll interject that I am familiar with Lion because I bought several of their batteries for my RV a couple years ago.
Yep.
And I really enjoyed their customer service, and they have quite a community of followers here in the U.S. So that was a very good experience, solid product. Lithium iron phosphate is what we're talking about, and I know that's the focus of ABF as well, is lithium iron phosphate. Differentiate lithium iron phosphate, if you would, that chemistry from some of the competing technologies that are used in both stationary and portable or electric vehicles.
Be more than happy to. In terms of lithium, there certainly needs to be a lot of education in the marketplace across a broad spectrum of folks that use the term. But a lithium-ion battery is a very broad umbrella, and there's multiple chemistries, many chemistries within that reference point. Just for simplicity's sake, I try to essentially put them into two different buckets. One is a lithium chemistry that requires a lot of power, essentially. On the EV side, you want to be able to move your EV from 0 to 60 fairly quickly within seconds. And so energy and the power side of that is very important. So the energy density associated with the key components is important. And so on the lithium side of the chemistry that deals mainly with EVs, they have a cobalt and nickel, and that allows them to really have a wonderful amount of power. But there's also pros and cons associated with that, which I'll talk about in a moment here. The other aspect of lithium batteries is really more along the side of an energy component, an energy capability, and that's where we're focusing with lithium iron phosphate. So the bucket that we are mainly focused in does not use cobalt, it does not use nickel. And why is that important? And how are these differences? Safety is really the key aspect for us. And with lithium iron phosphate, or short, we just call it LFP, is one of the safest chemistries out there. It actually was invented in the U.S. A couple decades ago. They did that in conjunction with Asahi Kasei, which is a large Japanese multinational as well. But this is a chemistry that's had a lot of testing associated with it. It's very difficult for it to catch on fire, to have what we call in the industry a thermal event. And if it does, conventional ways of putting out a fire work quite well on that for fire suppression. If we can talk briefly about the EV side, the more power-related cells that allow you to move very quickly with an EV, the cobalt and nickel are problematic. Russia has somewhere between 10 and 20% of the global supply of nickel, and that in and of itself causes issues in the supply chain. But let's talk specifically about cobalt. Cobalt is an incredibly energy-dense material that provides wonderful attributes in terms of really being able to move your EV along quickly. But the supply chain is challenged, is a nice way to put it. Most of it comes out of Africa, out of the Congo, and it's there's about 250,000 people involved with that whole process there, and it's really kind of a slave labor environment with that. About 10% of that are actually children. And so I know that they're trying to bring other sources online with that, but fortunately we do not have to use cobalt. We do not have to use nickel. We simply use lithium and phosphates and some carbon or some iron. So it's essentially fertilizer with some lithium mixed in. So it's a lot easier in terms of the supply chain to be able to source this.
Now, in terms of the performance of cobalt or nickel cobalt versus LFP, is there a delta, or are you able to tune that LFP chemistry to give you equivalent power?
Great question with that. LFP, the key differences between LFP and the cobalt and nickel lithium chemistries, as I said, is safety. The other aspect is longevity or cycle life. Typically with LFP, you're going to get multiple times, 2 and 3 times the cycle life. Our chemistry and our cells are really geared to last 20 to 30 years versus most EV batteries are in the 8 to 10 year time frame with that. So cycle life is extremely important to be able to do that. LFP does not have the same energy density associated with that, but the 3 areas in which we're focused is obviously energy storage, both at the residential, the commercial, as well as the grid level. The second area of focus is electric vehicles that have specific applications. And what I mean by specific applications, buses, trucks, mining equipment, vehicles that typically are industrial or commercially focused and want to last a very long time. Weight's typically not an issue for them, and safety is a big deal for them as well. And the third area that we're focused is military and government needs. We're in the midst of moving our entire supply chain to the U.S. and North America. Also, the key founders we're all U.S. citizens as well. This is homegrown technology that's been enhanced and augmented with consultants literally from around the world.
Well, I love it that you've got a storage product that seems to have many applications. I love the national security aspects of this. Renewable energy and energy storage are huge national security issues in general, because China is going after it very hard, and they are the gorilla in the room in terms of manufacturing power. Upwards of 70% of storage products are coming out of China and Asia. And, let's face it, the grid needs so much more storage. I don't have that number on the tip of my tongue, but it is massive. And, we clearly have the solar and wind and now energy storage technology to completely green the grid and green transportation and electrify transportation. And we're going to electrify heavy industry. It's just a matter of how quickly we can deploy. And so let's talk a little bit about supply chain and how is it that you're going to get your grubbies on enough lithium and other materials that go into these batteries?
Yes, and that is a massive challenge. If you don't mind, I'd like to give a little background on the grid side, and then we can certainly go into the supply chain. But sure. The estimated need within the U.S. By the end of this decade is about 6,000 gigawatts of energy storage. So 6 terawatts of power. That is a tremendous amount of energy storage that's necessary on this. And the percentages, you're correct. It's over 70% of all lithium cells are currently manufactured in China. If we look at specifically towards LFP, lithium iron phosphate, it's over 90%. And it's there's very, very little production of LFP cells outside of China. And in the U.S., it's simply it's not really been scaled to volume. We expect to be the largest supplier of LFP prismatic cells actually in the U.S. So in terms of the supply chain, it's definitely challenging. Fortunately, we've only got a couple dozen or so components that go into our cells. I'm happy we're not building a car because it would be much more challenging. But in terms of lithium and iron and phosphates, iron, plentiful in the U.S. and North America. Phosphates also need to be able to have increased volume production in North America, and that's on its way with that. The lithium side is definitely a challenge. I've had a chance to go out and look at different locations around the world. Here in the U.S., I had a chance to go to Thacker Pass, which will be announced, I believe, to be the largest supply or reserve of lithium globally. And it's on the border of Oregon and Nevada, about 3 hours from civilization, shall we say. And I had a chance to spend a whole day there with a PhD that literally had written their dissertation on that particular area. And what I can say to that, it's really kind of amazing on that, how all the parts and pieces from the environmental perspective came together 60 million years ago. And the way this has been approached has been very environmentally conscientious from that perspective. They've also included the native tribes in the area. They've been very aware of the water usage. In fact, they purchased a farm that was in the area, so they could actually have a water capability and water rights. So the net effect is that there's no additional usage of water. I listened to an NPR segment on this literally when I was flying back, and it was really interesting because so much of the information simply wasn't accurate. And I was very impressed with the way in which they have gone about really taking it to the next level in terms of making sure that we're doing this safely, soundly, and with good stewardship towards the land as well as the people in the area. So that's one area in which there will be lithium, and as they scale that up, there's multiple other areas from the Salton Sea in which they have brine. They are extracting lithium, and from mine locations as well as hard rock. The U.S. has lithium. The challenge is that they haven't been able to scale it up as quickly as necessary, and I certainly hope that that's something that will indeed be able to be scaled very quickly. Other areas in the world have had a jump on this. As I said, China's been making making batteries for a couple decades, and they've been able to put together a supply chain that is pretty remarkable. Australia is a key source of lithium, along with the Golden Triangle in South America, where you have Argentina, Bolivia, and Chile. And that's where the bulk of the current sourcing on lithium is coming forth. I am a big believer in supply and demand in terms of motivation. As the demand for lithium has accelerated, the exploration and the processing has also increased. The challenge we have in the U.S. is that we have environmental regulations, which it makes it quite challenging in order to do this. We also have an environment in which anybody can sue anybody for anything. And it's been interesting to see really what business some of these companies that are in the business of supposedly providing lithium in the marketplace. I asked one of the CEOs, how much time do you spend, relative to dealing with litigation versus actually extracting the product? And he showed me page after page after page of lawsuits that they've had to deal with in the last dozen years. So I really hope that this is an area in which we can move forward with. A couple weeks ago, I was in Detroit chairing a conference on supply chain, and director of the energy was there that dealt specifically with this sector. So, and that's one of the conversations that we're able to have at the conference on that. And they're aware of the challenges, and they're trying to make it easier, but making sure that all the parties are properly represented at the table.
Hey, everybody. Thanks for listening to the Clean Power Hour or viewing it on YouTube. We do have a great YouTube channel. If you're not subscribed, please go to cleanpower.group and hit that YouTube icon and subscribe to our channel. Of course, you can find all of our content on your favorite audio platform as well. So please give us a rating and a review. Back to the show. So when you think about scaling lithium iron phosphate cell production here in the U.S., and we should note that you have recently announced a factory that is going to get developed in Tucson, Arizona. A photo of that is behind you. Tell us a little bit about that project and, what are the things that are keeping you up at night? It sounds like you're working out the lithium supply chain, crossing fingers for that. But tell us about Tucson and what are your plans for scaling?
Absolutely. Just quick additional comments on the supply chain aspect of this is that we have what we need in America and in North America. Canada is coming on. Mexico has incredible resources on that. We simply haven't scaled to the volumes that we need to have. And the numbers and the projections that I've seen, we're going to be in deficit positions for the next several years on that. But I'm a big believer in the innovation of people here in this country. If there's a need, if there's a demand, the ability to adapt and create new technology, which will allow us to bring what's necessary into the marketplace, is something that has always been a part of the American perspective and dealing with a lot of inventors over the last 30 years. We just need to be attuned and sensitive and support those that have ideas that may be a little bit different, but let's see about that and how we can scale that. So relative to our announcement last week, and this has been a long time in coming, the journey has been literally about a year looking for a location in which we could have our headquarters and be able to grow out from there. First, I want to make sure it's really clear in terms of our perspective of what American Battery Factory is doing. We've had a chance to really understand how the rest of the world is standing up their factories, and we're taking a distinctly American approach to this. We've reviewed every aspect of the manufacturing aspect, including the supply chain with this. And American Battery Factory's implementation plan is to actually set up a network of decentralized factories that are using rapid construction. So we're starting with this first location in Tucson, of which I'll explain a little bit more in a moment here. But we will be expanding out across the U.S., across North America, and across the world. The idea and concept is quite unique, and it's really been embraced. We've had multiple countries fly in and to meet with us because they want to be a part of something that makes sense. And it also takes into effect so many aspects of being able to produce a product that's sensitive to the local area. So in terms of Tucson, Arizona, we started, like I said, about a year ago, looking at states all across the U.S. here. We've got an extensive criteria and scoring list of which we try to stay true to that, but also are open for additional ways in which to evaluate sites. We then moved that down to about 12 states and did additional due diligence on the opportunities to work within those states. And then from there, we went to 2 states, and ultimately it was really Arizona that won out. They were one of the very first states that gave us a proposal, literally, I think it was in January of this year. And that proposal really kind of turned out to be the standard by which all of their states were really compared to. They, referring to Arizona, really understand the need and the process by which an ecosystem and supply chain can be put together. There's a lot of companies in the electrification space that have found a home in Arizona, and we clearly understand why on that. Once we were able to narrow it down to Arizona per se, we then looked at sites all over all over from north to central down to south. And at the end of the day, it was really the people to be able to sit down with the mayor of Tucson and to be able to understand and see her vision, to be able to talk with the local utilities, the educational institutions that were there, along with the economic development people there. It was refreshing. It was wonderful. And it was really kind of interesting how Tucson had almost been overlooked because so much of the focus is on the Phoenix Valley, right? It's 100 miles from east to west, lots of activity up there. Tucson is about an hour and a half, 2 hour drive south of there. And what we've found is a lot of the companies that are stationed and positioned in Phoenix are starting to put their R&D centers, their test tracks an hour south of there. So just on the way to Tucson. As we looked at locations in Tucson specifically, we were able to find a great area. It's 267 acres right next to the airport, and it's part of a large aerospace research park that they've been developing and bringing online here for a decade. To be able to walk to a site that needed very little changes in terms of the topography itself, but to have most of the utilities stubbed right there was pretty refreshing, to say the least, and to have the local utility TEP step up and say, we will make sure that you have power. And that's one of the biggest challenges that we find in the U.S. is finding sufficient power to run these factories. It's a lot of power. You can run a smaller city off the power that we need in order to actually fabricate the cells. And unless you've planned ahead, you're not just going to pick up, the ability to order transformers and substations and things of that nature. They are years out in terms of componentry. So to be able to have a location that really had the foresight to be able to prepare the location for a company like ours was wonderful. Let me talk specifically about what will be in Tucson. This will be our global headquarters, from which we really will be inviting the world to come and see how you can manufacture in a clean and green environment using rapid construction. We'll also have an R&D center there with a fairly good number of PhDs and technical people. We also will be adding what we call our foundry. And our foundry is a gigawatt level machinery that allows us to take technology that works really, really well in the laboratory at the bench level, but it simply hasn't had the chance to scale. And that's something that's not available currently in North America. Essentially, you really have to go to China for that. And from a national security issue, that and a funding issue, that really isn't an option for technology that's been funded by the U.S. government. And so our foundry will be really, from our perspective, a national resource that will allow us to take technology and scale it up. Some of it's going to work and some of it's not going to work. But to have the ability to make sure it's going to work in a gigafactory before you put it in is a unique aspect. And that's another comment that I'd like to make on that there's wonderful, wonderful technology that's been here for years, that simply is not being used in gigafactories because not many people are going to shut a gigafactory down and introduce something new and in the hopes of making sure that it works. The foundry will allow us to do that. And then the last thing I'd like to talk about, obviously, is the gigafactory itself. We're doing this in a pod or a module approach. And we're using a rapid construction technology with a structure that's called tension membrane. Each of these pods or modules will be producing between 3 and 5 gigawatts of annualized production. Early on, when I talked about decentralized manufacturing location, we're serious about that. What you typically see in these large gigafactories are large monolithic facilities that can literally take thousands of acres, and some of them are 10,000 or more workers, and they need massive amounts of power. So when you add all those characteristics that they're looking for up, you're talking about a rural environment. There's not many places in the U.S. or frankly in the world that have the workforce available and the power available in these rural environments. So rather than doing that, and literally it can really change the nature of the announcement of such a large monolithic gigafactory from something that's wonderful, billions of dollars, wonderful announcement, to the reality of how do they find the workforce? Are they ending up, poaching from 7-Eleven and from local businesses? It goes from a wonderful situation to, this isn't really great for the local businesses. So our perspective is to understand what the resources in an area are first, and then scale this accordingly. We use incredibly automated and robotic equipment And we believe will be the most truly automated cell factory in the world because of the U.S. technology that we will be using. But we're able to scale our factories from 300 people to 1,000 people. And that allows us to be able to produce anywhere from 3 to 16 gigawatts on an annualized basis. Let me pause for a moment because I'm sure you have questions.
Well, this makes me think about Tesla and their emphasis on building the machine that makes the machine. And so, I love it that you're hardcore about an efficient construction methodology and building a factory with components as much as possible that are coming from the U.S. When you compare yourself to what Tesla is doing, how do you compare in terms of your ability to scale to volume? Because obviously 6 terawatts is a lot of batteries, and we need to be producing hundreds and hundreds of gigawatts per year. How do you see that?
Yeah, and by the way, Tesla has really they've been amazing. I mean, frankly, they coined the phrase gigafactory, right? And they did not even trademark it, but they did trademark gigabeer. Anyway, that's a whole nother conversation. But there's so much to learn from Tesla, and incredibly appreciative of the vision and how they've actually been able to execute on that. The tension membrane structure that's behind me here, I actually discovered that about almost 9 years ago now. Tesla has used the same tension membrane technology in their Fremont facility when they stood up 137,000 square feet or so in 19 days. So it's been used in the manufacturing space, but nobody's ever used it in the battery space before. And some of the interesting attributes on that is that it's the structure itself that's, as you pointed out, the virtuals behind me here, can literally be fabricated in North America, 500,000 square foot building in 10 weeks. And then it can be shipped down in shipping containers and stood up in about 10 weeks. It's seismic rated, 180 mile an hour sustained winds. It's LEED certified. There's essentially no waste at the site, and it's airtight. And it's about 30% cheaper than traditional construction. One of the challenges that other gigafactories have is a lead time on an I-beam. Recently, I was told was 53 weeks. So it takes a long time to stand factories up. So utilizing existing technology, but applying it in cell manufacturing allows us to be able to stand up our factories very, very quickly. And being attuned to enhancements and other technologies and being open to being able to implement these is super important to us. In terms of scaling, the first pod that we have here, we believe that we'll be able to be in production in 2024, the later half. We've also been able to put together a global, a multinational team of the best of the industry in each of their sectors. So far, we've announced Asahi Kasei. As I mentioned earlier, they literally were one of the companies that invented the lithium ion battery. They're also a supplier of a key ingredient with that. And that relationship has been absolutely wonderful. They've opened doors and allowed us to really understand the technologies that are out there. We've also had a strategic partnership with the largest supplier of synthetic graphite here in North America. We'll be announcing strategic partnerships with a very large multinational that will be working on our supply chain to make sure that all our factories have sufficient levels of raw componentry. We will be announcing also a strategic partnership 10-year teaming agreement with one of the best automation companies on the face of this planet here. And a couple other companies of that nature, particularly an EPC company that has done projects in virtually every country around the world. So we've basically gone out and tried to find the best in each of these sectors, pull it together, focus on North America initially, and then from there we'll grow it out. This first location in Tucson will truly be a template. Every single bolt, the torque factors on those, and every aspect of standing this thing up will be documented. So when the next factories are announced, they'll go up quite quickly. Essentially a factory in a box, 500 to 600 shipping containers show up. The structure comes out, the equipment that fabricates the cell comes out. And we're able to stand these things up very, very quickly. We can do the calibration and commissioning because of the incredible level of automation. It will really be a new standard by which factories can be stood up very, very quickly. And so in terms of being able to reach that need and the demand, all I can say is after we do this first one here and learn the things that we don't know right now, we will then move very, very quickly in North America and around the world to stand these factories up.
And so tell us about the 5-year plan and how many gigawatt or gigawatt hours of production do you see ABF reaching in the next 5 years?
That's also a wonderful question on that. What I can refer to is the public information that we've provided in Arizona. Over the next 5 years, we'll grow from 3 to 16 gig at this site. That's what we've said publicly, based upon demand and available resources as well. We've got plenty of room to expand at this 267-acre campus. We also have been approached and will be accepting proposals for co-location partners on this. And what I mean by that is we just make the cells. We then provide those to system integrators and pack integrators. They actually turn our cells into something of value that you can buy at Costco, or you can, or the grid can buy a 40-foot shipping container that's ready to go. And that's done with the groups that are able to take our cells, essentially like Legos, put them together, put battery management systems on them, and cooling systems, heating systems on that, and have a product that you can put in your house or in your business or at the grid level on that. So we've got a couple companies that have already requested to co-locate with us. That's why we have additional property on that. We also hope to have additional manufacturing that's further upstream, where the processing is actually will be occurring, and whether it's the cathode material or whether it's certain components that go into the cells. We want to have a complete, viable ecosystem that's rather broad-based at our particular location with that. And we really think that it's a good model in order to grow and to move forward with, not just here in the U.S., but other locations around the world, of which we will eventually help to create regionalized and potentially country, sovereign-specific supply chains relative to this.
And what can you say about customers?
The need and the demand far outstrips the supply. We want to make sure that we allocate our production based upon those companies that we really believe are serving the right area, the right focus, and very much have a perspective of stewardship to the workforce along with the environment. As we've just talked about here, the demand is actually rather massive. There's very few entities in North America, or frankly outside of China, that are really focused on using lithium iron phosphate in a prismatic can. Most of them are using a different form factor. A pouch is a common form factor on that, or a cylindrical. But to be able to use a large aluminum can, there's actually a lot of technology that goes into that. And when you have a cell that's built to last 20 to 30 years, to have a chemical reaction that occurs within a enclosure, you want to have that thing as strong as possible with that. So in terms of where we believe that the volume will go, as I said, as soon as we do have this first plant up and running and things are going well, we will be expanding out very quickly. And really, it'll be dependent upon what the workforce environment and the power capability in a particular area is. In terms of workforce, we've partnered up with a local community college that has put together these centers of excellence. In Tucson, for instance, in the next few months here, they'll be completing an advanced manufacturing center that will be training our employees. You couldn't write the game plan any better than this. Beautiful state-of-the-art facility. We'll be working in conjunction with them to create a syllabus to train them. And so as they come out of that program, and these are many programs that last for a few months, they then are able to go directly onto the line, as well as into other areas within our factory itself. I do want to mention, too, that we have an apprenticeship program that we're continuing to expand that literally starts at the high school and goes all the way through PhD programs. So we're big believers in making sure there's hands-on opportunity for those students that would like to be able to do more than just read something out of the book or look at a video. Well, they'll actually be able to be in a state-of-the-art facility, whether it's R&D or whether it's controlling these robots and automated vehicles. It's going to be a pretty cool situation with that. So to net it all up, we will move as quickly as we possibly can, and we're trying to address every single issue that we're aware of on the supply chain in order to mitigate those and to increase the volume and the quality of those particular items.
Well, I'm glad you mentioned workforce, and we like to be a conduit here at the Clean Power Hour, so reach out to us if you're looking for a connection in the clean energy transition. We love to make introductions for our listeners. Please check out all of our content at cleanpowerhour.com. Subscribe to our YouTube channel there. Just click on that YouTube icon and give us a rating and a review on Apple and Spotify. That helps others find this content and helps us speed the energy transition, which is our mission here at the Clean Power Hour. I want to thank Paul Charles for joining me today. Wonderful news about homemade lithium iron phosphate batteries here in America. We wish you the best, Paul. And how can our listeners find you?
Please go to our website, AmericanBatteryFactory.com. If there's interest in collaborating with us in any sense of the world, please fill a form out. If there's interest from the workforce perspective, there's forms on that as well, too. We're here to help establish a supply chain to help America.
Thank you so much. I'm Tim Montague. Let's grow solar and storage.